And I haven't said this before, but I am going to ask when we're going through lessons, have computers, yes, computers down, computers away, please. So today, really the main thing, and I always have the I can statement on the front board too, but we are, well, I have the I can statements right on the sheets as well. But identifying and using special pairs of angles says we're going to see like adjacent angles, it's a pair of angles, and so on down the sheet. And then also identifying and using perpendicular lines. That's what we're looking at today. And by using them, it's just using them in problems. So once you know the relationship, how can you use them when you're problem solving to, make an equation or whatever it might be. So we're starting out with adjacent angles. And these are two angles that lie in the same plane and have the following. So they lie in the same plane and they have the following. They have a common vertex. They have a common side, so they share a side, but they have no common interior points. Adjacent, I will say adjacent is a fancier term for like next to. That's how I think of it. So adjacent angles are angles that are next to each other, which is why they share a common vertex and a common side, but they're not like the same angle. There's not one inside of the other, so that's why they don't share any interior points. Adjacent, it's a term that's used outside of math as well. If you ever hear like, this is adjacent to something else, it's next to something else. So notice the way this table is set up, we're going to actually draw out examples of what adjacent angles are, and then we'll draw out what would not be adjacent as well. Because sometimes it might be more helpful to see like what isn't adjacent versus what is. So here's one example. So if I have this angle and then it's split, not necessarily in half, but if it's split like this, and I call one of them angle 1, one of them angle 2. Those would be adjacent angles. They share a vertex. They have a common side. I'm just going to draw one other picture that doesn't look the exact same. Because sometimes when you have maybe obtuse angles in there, it looks a little different. But even this, those angles 1 and 2 would also be adjacent. They share a vertex. They have a common side. Maybe I'll even highlight that. Vertex, common side, vertex, common side. So that's the key. Share a vertex, have a common side. But notice it's not like one of the angles is inside of the other one. So then here's, I'll list some examples that are not adjacent, or draw some examples that are not adjacent. I'm going to draw a similar picture to this, but label it differently. Similar picture. I'm going to label this as 3, and then I need to label some points here. So this one, again, picture, I labeled it differently. Picture looks the same here. But in this case, if I'm talking about angle 3, and then I have angle ABC, so notice since angle 3 is included in angle ABC, even though they share a vertex and they technically share a side, they do have common interior points because angle 3 is actually inside of angle ABC, so these are not adjacent, so are not adjacent. If you wanted to add more notes to yours, angle 3 is actually inside of angle ABC, and that's why they are not. Or here, I'll draw another example, and I'll still label angle 3 and angle ABC, but it's going to look a little different here. Sometimes you see pictures like this, kind of looks weird. So if I call this angle 3 over here, and then I have angle ABC here. So for both of these pictures, angles 3 and ABC are not adjacent. And here it doesn't meet these first two criteria because they don't share a vertex, nor do they share a side. They don't have any common interior points, but they don't meet the other two. Okay, so you see adjacent and then not adjacent. Adjacent is fancy for next to. Questions there? Next one is linear pair. These are also, all of these vocab, I've said this before when we were going through segments and angles in the last couple of lessons. This vocabulary comes up in proofs. Linear pair comes up a lot in proofs in terms of, there's something called a supplement theorem that we'll talk about. But a linear pair, these are adjacent angles whose non-common sides form opposite rays. What did we say yesterday? That opposite rays form a line. So, in short, a linear pair are two angles that form a line. So actually, I'll fill in this part in a moment, but this is a picture of a linear pair. So here we have a line. So if I say this is angle 1, this is angle 2. Okay, so two adjacent angles, they are adjacent, they share a vertex and have a common side. And then their non-common sides, these two sides form a line. And then we did talk about yesterday how the angle of a straight line is 180. You had to use that actually in the very last question on the assignment. So angles in a linear pair are supplementary. They're called supplementary if they add to 180 degrees. So that's, in case you can't see that, supplementary. So angles in a linear pair are supplementary. So that means, just in the way I drew this, the measure of angle 1 plus the measure of angle 2 should equal 180 degrees. So then a picture of something that's not supplementary would basically be adjacent angles that don't form a line. I'm going to put 3 and 4 here. Still adjacent, but their two non-common sides clearly do not form a straight line. So they're not a linear pair. And we'll talk more about supplementary as well. So there is a difference between being a linear pair and being supplementary. Supplementary just means two angles that add to 180. Linear pair is specifically two angles that form a line. So they have to be adjacent angles. All right, the next one, vertical angles. For whatever reason, this is the one that is like the most forgotten, but it's also very, very important. So vertical angles comes up a lot. And I don't know why it's forgotten a lot, but it is. So if you want to put like stars next to it as a way to draw your attention to it. So these are two non-adjacent angles, so they're not right next to each other, formed by intersecting lines. non-adjacent angles, bless you, formed by intersecting lines. And I'll draw what this is, but what's so important about vertical angles is they are always congruent. Vertical angles are congruent. So when I have two lines that intersect, notice what I get as a result, I have four angles then that all have a common vertex. These are the vertical angles, the ones that are kind of like opposite or across from each other. So these are vertical angles. If I have angle 1 here, angle 2 here, those are congruent angles. They are vertical angles. Also, because when you have two intersecting lines, you get two pairs of vertical angles. These angles here are also vertical angles and are also congruent to each other. So if I call this angle 3 and this angle 4, these I'm going to put two arcs. Those are congruent to each other. So not all four are congruent to each other. They could be, but not necessarily the case. These two are congruent and these two are congruent. So you get two pairs of vertical angles. So a non-example would just be like you don't have exactly two straight lines that intersect. So maybe you have one line, you still have four angles, but like the second one isn't quite a line, something like that. So if I have here 1 and 2, and then 3 and 4, I don't fully have two intersecting lines. Okay, questions there? So when you're told that two angles, if you're told they're vertical angles, thinking ahead to a problem, if you have to set up an equation, you know that you can set them equal because you know that they're congruent. All right, then we have complementary and supplementary. I told you we'd come back to supplementary. So complementary angles are two angles that have a sum of 90 degrees. What does sum mean? They add to 90, yes. And then this is just some vocabulary that goes along with it, like saying an angle is a complement to another angle. That means that angles 1 and 2 are complementary. They add to 90. So here's, I'll just draw a couple of pictures. You could have two angles that are adjacent. So say I have like this 90-degree angle, and then doesn't have to be split in half exactly, but if then I call this angle 1, this angle 2. So I can clearly see that angle 1 and 2 add to 90 because they form a 90-degree angle. They're adjacent. But these do not have to be adjacent angles. So say you have two separate pictures, like I have one angle over here, and I know that it is 30 degrees, and then I have another angle over here, and I'm told that that is 60 degrees. And I'm just going to put, this isn't correct labeling necessarily, but to go along with this, say this is angle 1, this is angle 2. Even though they're not adjacent, they're not touching at all, they still are complementary. They still add to 90. So complementary angles don't have to be angles that are touching each other. And then supplementary angles, we already talked about this with linear pairs. These are two angles with a sum of 180. And so that vocabulary too, angle 3 is a supplement to angle 4, would mean that the two angles are supplementary and add to 180. So we do have that they could be adjacent. So like 3 and 4. This then tying into what we did on the front, this is a linear pair because they are adjacent and they do form a line. But to be supplementary, like I mentioned on the front, they do not have to actually touch. They don't have to be a linear pair. So kind of like this here, if I have like this angle is, say, 100 degrees, and then I have, oops, this angle is 80. So they're not a linear pair. So not linear pair, but they're still supplementary, both cases. Just trying to stress that difference to you early. Okay, so then that's really answering questions 1 and 2, but we'll still write these out. So 1 says, what's the difference between supplementary angles and a linear pair? So just making sure you're paying attention. Somebody, can you say the difference? What's the difference between supplementary angles and angles that are a linear pair? Angelina? Yes. So a linear pair, I'll say must be adjacent and form a line. And then we could infer from that supplementary angles must not, they don't have to be adjacent and form a line. But then this kind of ties into number 2, true or false. Supplementary angles always form a linear pair. I've already answered that. Supplementary angles do not have to be a linear pair. So this is false. Okay, and then I just have here, it says name the supplement and the complement of each angle. So kind of going off of this, the complement and the supplement are what get them to add to the correct sum, either adding to 90 or adding to 180. So if I have a 60-degree angle, what angle would be its supplement? 120, since 60 plus 120 is 180. What would its complement be? 30. Okay, so if I have 45, what's that supplement? 135 is what would get it to add to 180. What's its complement? 45. And then this one's a little trickier. So if then for any angle, if I just have n, yes, is that you feel that? Yeah, so the supplement would be, you'd have to calculate it 180 minus whatever n is, would get you its supplement. So then what would get you its complement? 90 minus n. Okay, and those might have been the calculations you took to even get these answers up here. Okay, questions so far on those? Okay, then those are angle pairs. Now we're looking at perpendicular lines. What's true about perpendicular lines? Well, they're perpendicular. What does that mean? They intersect. What's special about their intersection? Because I drew intersecting lines here. Are all intersecting lines perpendicular? No. Ty, did you have an idea? Yes, so perpendicular lines, when they intersect, the key is that they're forming 90-degree angles or right angles. And now even on this picture, even though only one 90-degree angle is labeled, all 4 of these are actually 90 degrees. if you know that you have intersecting lines and one of the angles is 90, then you know all 4 of them are 90. So perpendicular lines intersect to form 4 right angles. Now another way to phrase that, if all angles are right angles, all angles are 90-degree angles, it also forms congruent adjacent angles. So this is the case, like these are technically vertical angles here, but they are all 90. So it's 4 congruent adjacent angles. Segments and rays can be perpendicular to lines. Now I am gonna put a symbol here, but I'm gonna write it down here first. And you might have seen this in algebra because I know you did write equations of perpendicular lines. The upside down capital T, this is the symbol for perpendicular. So this means perpendicular to. Okay, so if you have notation-wise, like right here, if you look at example 1, we're not at example 1 yet, but if you look at that notation, this is line PR is perpendicular to line SQ. So that's the notation for it. So segments and rays can be, I'm going to put the perpendicular symbol, perpendicular to lines or other segments or rays. And then the right angle symbol, so that's this box right here, but if you wanted to in here just show, that is what tells you it's 90. So the directions for a problem, either you have to have that symbol or it has to tell you it's 90. You cannot just look at it and say, oh, that looks like it's 90 degrees and make your own symbol in there. If it's not in there, then you can't assume that. But that indicates lines are perpendicular and then the angle measures are equal to 90 degrees. Okay, so example 1 says find x and y so that line PR is perpendicular to line SQ. So I'm just going to highlight line PR and then line SQ. Okay, so I have here to help you out, it says if line PR is perpendicular to line SQ, then the measure of angle STR. So STR, what must the measure of this angle be? 90. If those lines are perpendicular, STR must be 90. And then the measure of angle PTQ, that's this angle, what measure must that be? 90 as well. So you're setting up equations to find both x and y. So based off of this angle being 90, that means these two smaller angles we have, these must be complementary. They must add to 90. So one equation would be that 2x plus 5x plus 6, those two angles must add to 90. Okay, there's an equation I can solve. So if I solve this for x, I'll combine my like terms. That's 7x plus 6 equals 90. And I can subtract 6 from both sides. 7x is equal to 84. Divide by 7. 84 divided by 7. I think I heard somebody say 12. So x is 12. Or the value of 12 makes the lines perpendicular. Now I have to find y. Now this is actually the whole angle, so this means 4y minus 2 must equal 90. Because that already is the whole angle. So if I solve for y, add 2, 4y is equal to 92. Divide by 4. Anybody have 92 divided by 4? 23. Okay, and there's y. Okay, questions there? Okay, then I'd like you to work through example 2. Example 2 does not go with this picture. You can draw it if you need it, but it says find what x would be if the measure of angle D is 3x minus 12 and angle D is a right angle. Okay, and then that is the last example. Work through that. I'll pass out the assignment. I have one thing to say about the assignment, but I'll wait till everybody gets it. All right. Attention up here, please. I need your attention. I know some of you have this. There's no picture for this, so if you needed to, so these are both talking about some angle D, and you know that's a right angle, meaning its measure is equal to what? 90. Okay, so if this is 3x minus 12, 3x minus 12 must equal 90. Okay, solve that equation. X was 34, and it did just want you to find x. Okay, but that is a lot of geometry, is what equation do I set up and solve to get my answer?